Hello, everyone, and welcome to another Product People community event. We're really happy that you're joining us, and we're really excited about this topic. I think a lot of you are as well. So tonight, we're going to just be talking about what the role is of a product manager in a machine learning powered product. And we're joined by a very special guest from Amazon Web Services, Oren Steinberg. He's the head of AI and machine learning for the EMEA region in Amazon Web Services. And we can't wait to hear what he's going to be talking about with us in this topic. But just before we jump into that, I just quickly want to introduce myself. So my name is Stefan. I'm a product manager 1 at Product People. As you can see on the side, I've a few years of experience in product management, user research, UX design, market research, and then working with B2B and B2C products. So I started off studying LLB and doing articles and being an attorney, and then I slowly transitioned into more of the product space. And then I can speak English and Afrikaans. Afrikaans is actually my home language, so that's the language that I grew up speaking. I don't know if anyone has ever heard of that language, but that's the one that I'm speaking at home. And then just a little bit about Product People. So what we're doing tonight is something that we really love doing, and that's sharing knowledge generously with our product management community, which you are part of. And it's a 13,000 member strong community. So that's really something worth bragging about. As a company, we also really love discovering and delivering great products faster for other companies. And we do this by doing the hands-on and unglamorous work of a product manager on an interim basis, so 3 or more months. We onboard fast, we align teams, and we deliver outcomes. So just before we jump into Oren's presentation, we thought it would be good to just have a little bit of an icebreaker. 2 questions. So if you're on Zoom, you'll see a poll popping up in a few seconds. And if you're on any of the other streaming services, you can just pop your answers on the chat. If you're on Zoom, you can just vote on the polls. So the first question is, when will your product include machine learning? So the product that you're currently working with. A, mine already has. B, before the end of the year, so this year, 2022. C, next year, 2023, or D, later. And then the second question is, what do you need to start working on a machine learning powered product? So here you can choose more than one answer. It could be A, use case that fits machine learning, B, lean proof of concept, C, data, D, collaboration with data science team, E, user adoption, F, feedback loop, or G, others. And if you have others, then please share them in the chat so that we can see what the other thinking is there as well. So I think on Zoom, you can see the poll popping up right now, so you can vote on it. And I think it will be quite interesting to see the different answers that we get for when your product will include machine learning, because I think many of us are kind of assuming that a lot of companies already have machine learning, or that it's in the very close future that people are building it. But that assumption might be wrong, and I'm looking forward to seeing what the answer is there for all of you. And then what you need to start working on a machine learning powered product. So I think all of these questions, answers are pretty valuable, but I'm also looking forward to seeing if maybe there are some other things that we haven't thought of that you actually apply when thinking about a machine learning product. So a lot of the answers that I'm seeing are within next year, and then also before the end of 2022. So that's really cool. So it might not already be there, but it is in the roadmap. And I think we're already in June right now. So that's actually quite close when it's still in this year or within next year. And then there are some of you that also says that you already have it included in your product, which doesn't surprise me that much. So not really seeing people that are saying later, which is actually quite cool. Oops, sorry. But I was wondering if we were going to be proven wrong. Oh, so now on Zoom, you'll see the new poll coming up. We had a bit of a technical glitch with the previous one, so you can vote on this one. And then there's a lot of people that are saying that what they need to start working on a machine learning powered product is collaboration with data science team. I think that's pretty accurate. And then other people also saying that use case that fits machine learning, user adoption, and data. A lot of answers coming through around data, and I think that's pretty accurate, because the things that I've seen so far have also been like, you're like a product manager, but very good at math and data. So I think the data and collaboration with the data science team is something that I was expecting to see. And then, yeah, someone is also saying here that, well, a few people are saying that the use case that fits machine learning. And I think that's always quite important. Like, what problem are you trying to solve? And not just implementing technology for the sake of implementing technology, but implementing it because it actually solves a customer need. So yeah, thank you everyone. I think, and we have the Zoom results as well. Most of you also here, there's actually a little bit of a change here. So there's a lot of people that are saying, there's about 40% of the people on Zoom saying that their inclusion of machine learning in their product is later. So not next year, not this year, not already, it's later. So it's actually cool, because I was wondering if I was going to see that a little. And then on why do you need to start working on a machine learning? Also, a lot of people saying use cases that fits machine learning, lean, proof of concept, and data and collaboration with the data science team. So that's really great answers. There's no one that actually gave an other and a comment there. So I was hoping to see something cool and different somewhere. But yeah, thank you everyone for giving us your answers there. It's been really cool to see where different products are. Now, without further ado, I'm going to be handing over to Oren to start with his presentation. So like I said, he's the head of AI and machine learning in EMEA. And we've spoken a little bit before, and he's really also passionate about this topic, obviously, and he's been sharing it in his environment as well. And you can also follow him on LinkedIn, where you'll see a lot of more of how he shares his knowledge on this topic as well. So I'm going to stop sharing now, Oren, and give it over to you.
Thank you. Right. Just give me a thumbs up. You can see my screen, all right?
Yes, we can.
Cool, thank you. All right, thank you. Thank you, product people. Thank you, Stefan, for the warm intro, and product people for having us. My name is Oren Steinberg. I lead the AI and ML team across EMEA for AWS. I've been here for 3 years. Prior to that, I've been a product manager for about 15 years. Some of that in insurance, insurtech. Some of it is in healthcare, in DNA sequencing. Almost all of the product roles I had involved one way or another some machine learning and AI capability. I'm very passionate about machine learning and AI. I'm very passionate about product management. And actually bringing these two worlds together is kind of my baby in the world, right? That's what I'm passionate about. That's what I love doing. So thank you for inviting me to your ML journey and your product ML journey. And let me see if I can shed some light on some thoughts and ideas of how to do this better. We're going to cover the following topics, and based on the poll, I'm probably going to focus on the three that you highlighted. The use case, how do we find the use case that is a good fit for machine learning, which is basically the 2 bullet points. A, what is the methodology for identifying problems that are worthy? And then B, how do we qualify whether this should be a machine learning problem or not? I'm going to talk about POC. I'm going to follow Marty Kagan's approach, and I think that was one of the third topics that was highlighted in the poll, so that's great. I'll touch a little bit on team, because some people mentioned that, even though there's less percentage, but still I'm going to talk a little bit about how do we collaborate, product managers and data scientists, even though we sometimes feel like we're coming from different worlds. I'm definitely going to talk a lot about the data aspect. How do we identify if it's a good data, bad data, missing data, which is usually the key element, missing labels in the data. And then I'm going to close up with how do we earn user trust, going from a model to a product, and how do we capture the feedback to close the loop, basically. What we call in AWS the ML flywheel. When we talk about a product process, we always start with a problem, use case, KPI. We then design some sort of a POC. In traditional non-ML products, we then hand it over to the engineering to build it, and we get it back when it's time to plan the launch. In this case, it's kind of the modeling. But within this space of modeling, there are different elements that I think are important to dive into a little bit, because it's not really a handoff to the data science team to build and forget. There's an element of data selection and labeling, in the sense of being able to tell the machine, it's not a machine learning training, but just kind of we understand, talk the same language here. Machine learning is usually split into supervised and unsupervised. In supervised learning, we tell the machine what is the answer to the test. Like, here is 1 million pictures of a dog, 1 million pictures of a cat. And then for 2,000,001, let the machine try and identify on its own. That's the real test. But we gave it originally all the labels, which are the tagged answers on the training data set, for the machine before the actual questions, before the inference phase. Being able to choose what data to label, how to label, who is the labeler. Think about healthcare, for example. If you're working in the space, if you want physicians to trust your model, they would want to know who labeled the data. Was that really an expert physician in that specific field who labeled the data? They would lean more towards listening to the result of the model versus others. So that's one aspect of this. Modeling talks about feature engineering, which is usually 80% of the time that data scientists work on a model is around feature engineering. Let me explain that term just so for the benefit of people who are not familiar. If you're working in location-based services, GPS-based data, and let's assume the raw data is longitude and latitude, feature would be the meaning of that location. Meaning, so would say, let's overlay this longitude and latitude over a map and say, is this a high street? Is this a shopping mall? Is this a football game? So all of a sudden we're saying it's not just longitude and latitude, it's actually in a football game, stadium, during a game, or just before a game, or just after a game. And at this time, in this location, the weather was really hot. So if we're now forecasting the consumption of soft drinks in that area, that is an important feature for us to have, as opposed to just, hey, longitude and latitude without the context of football game time, location, and all of that. HPO goes to the hyperparameter optimization, which is kind of how do we tweak the black box. Machine learning, deep learning specifically, which is a subset of machine learning, is characterized by having an input layer, an output layer, and some hidden layers in the middle. Call it a black box, but it's not really. We can control some elements. We can control how many layers. We can control how the data moves within that black box, how the data that comes in, how do we weight? We age the data. If we're looking at data that's pre-COVID, maybe now it's more relevant, the data that is in the peak of the COVID, for forecasting different things. So influencing all of that falls into what we call HPO, hyperparameter optimization. Metric selection and optimization. Again, it's not just a data scientist's job to do that. Think about a recommendation engine. Now, as a product manager, if you're designing the recommendation engine for a large screen, then you may be good with having, I don't know, let's make sure the user at least chooses 3 out of those 5 top recommendations. Not necessarily buys these products or watches these videos, if it's like Netflix sort of recommendation, but at least hovers over them for a little more than the usual. But if you're on an app on the go with a very small real estate in your UX, you have to have a next, like a frictionless process, and you have to have 1 out of 1 recommendation. So the math needs to work differently if you're trying to optimize for 3 out of 5 versus 1 out of 1. These are inputs that product managers can provide to the data scientists so they know how to design the right math, choose the right algorithm, choose the right target function. So that's why you can't really hand off the modeling piece to data scientists. You as a product manager have to be involved in this process. And of course, once the model is ready, you want to take it into a product. We'll talk about going from model to product. And the gap there is usually user trust. How do we get users to trust the machine learning model? Some areas, it's not that big of a deal. If you're just recommending me which videos to watch, I'll just watch the preview and then decide. But if you're sending me to do a medical exam based on a recommendation from a model, I need to know a little more about this, and I need to trust the system a little more. And finally, how do we close the loop with a feedback loop? When we talk about the role of the product manager, we as product managers lead the problem statement and we lead the feedback. We're masters of the analytics, right? We take the data from the users, we're the voice of the customer back to the company. We're equal contributors in the POC phase because we got to figure out what is the right assumption we want to de-risk. And maybe we're even more than contributors. Maybe we're even leaders in the productization and launch. But the interesting piece is the middle here. In the modeling, we're actually equal contributors in data selection, which features we want to choose, which labels and which labelers and which target function we want to optimize for. So whenever you talk to or work with a data science team, do not think of a handover process of the model, and think of a joint, collaborative, empowered team, as Marty Kagan in his recent book said. Empowered team is a product manager and a data scientist working not just on the problem statement, but actually working on the modeling process together. Now, the reason I joined AWS, because I heard a talk by a product manager from Amazon talking about the methodology that's called working backwards, or as we often call it, PRFAQ, which stands for press release and FAQ in one word. Basically, what we do at Amazon is we don't write MRDs and PRDs like I used to do in my previous 15 years of product management. We actually, when we have an idea, we write the press release. But think about this kind of, we even thought about how to do it. We didn't draw any mock-ups. We actually say, let's assume the idea is good. Let's assume it's working, it's doable. How does the press release look like? We're starting at the very far end. And the essence of the press release is the customer quote. Who do we quote? Is this an enterprise, an SMB? Is this in financial sector? Is this in tech sector? And within that, who is the persona that we're quoting? Because there's only one quote, right? Is that the CEO, the CIO, CTO, VP marketing? And within that quote, what is the one value that is highlighted? And we talk about PR people usually have very short attention span, right? So we got to really narrow it down to what is that one thing that the CIO of company X said about this product. It helped me save money, it helped me find new customers, it made me more productive. By distilling that value, we're actually then enabling ourselves to go into the product process much better. FAQ has two types of FAQs. We have external and internal FAQs. The external FAQs are all the questions that users will ask. How do I join? How much does it cost? What does it do with my data? All of those, even the hard questions, right? What does it do with my data? Do you use it to train others and so on? Everything we got to ask, even if we don't know all the answers, but we list all the questions. Internal FAQ talks about the questions that your CEO and your internal stakeholders will ask. How do we make money of this? Will it hurt our brand? Will it cannibalize other services? How do we train the field to sell it? All of those, again, ask all the hard questions. Try and answer as many as you can, but only after you write down the press release and the PR and the FAQ, only then do we go to the visuals, which is the mockups and all the wireframes that people do. For machine learning, I strongly recommend you to run these workshops within your organization. It's a thinking process, a discovery process where you invite a business owner, the person who owns the KPI in the business, more customers coming in top of the funnel in the marketing space. HR who's looking to improve the process of recruiting and hiring and training people. Whoever that business stakeholder is, someone who knows the data, what data exists and how to get it, and someone who's technical, could be the data scientist, could be an engineer that's later going to be in charge with building it. And ask them to follow this process. Ask them if they knew X, they could do Y in order to get Z. Right? It's not enough to say, I really want to know what will my revenue look like next quarter. Is that really actionable? You know what? Yeah, I can probably generate a report to the regulator because I'm a public company and I need to generate these reports on a quarterly basis. Okay, cool. It's actionable. What is the ROI on that? And people kind of get lost. How do I quantify that? So the best way to think about this back of the envelope sort of approach is to say, let's assume, and most BI, business intelligence type of models would require 4 to 6 months of the data scientist, 80, 100% of their time, and then about 10, 20% maybe to maintain it. Just look up the salary of data scientists in your region and say, this is the cost of building this model. Now you have the cost. Now ask yourself, is the value of automating those forecasts every quarter, is that business value enough to justify the cost? And all of a sudden you start to see that these stakeholders have a long list of cool ideas they really want machine learning to help them with, but either they're not actionable or they don't really have an ROI. So go through this in high scrutiny, make sure you're not biased towards machine learning just because it's a sexy new technology, but actually it has a strong, valid business use case. Here are some examples of companies and how they use machine learning, from business tools on the top left corner, forecasting, churn prediction, personalized engagement, optimized support routing, matching the right person to the right ticket or the right persona of rep on your call center to the right persona of customer calling in, fraud detection, and so on. Bottom left, consumer application, next best action, personalized recommendation, dynamic pricing, everything around chatbots and communication and computer vision, identifying images, subtitling, and so on. Top right, fraud detection, everything that goes to risk and identifying patterns in data, anomaly detection, and so on. And bottom right, BI stuff, right? Every company, regardless of the vertical, has this. You want to predict churn. You have a premium SaaS-based model. You want to identify which customers are likely to upgrade to premium so you can engage them better, sooner, faster, and so on. And if you follow the methodology I presented earlier, you could reach these example use cases. Again, try to be as generic as possible because there are people here from different verticals and industries. But the results of this discovery process could end up being which customers are likely to churn or at risk and when. So we can proactively reach out with adjusted offering around price, bundle support. What is the KPI? Reduce churn. So what is our churn before? What is our churn after? Let's do the math and lifetime value of each customer that we saved. Increase cross-sale, again, how much we sell, what products, and so on. Could be which support agent is best fit for each ticket based on the skill, the profile of that caller and the rep. And then we can do the right matching. The action is to do the right matching, faster matching maybe. And then we have improved SLA. You can reply better, maybe you can have higher satisfaction. Could be one or the other or both KPIs here. If you have any call center, how many calls are coming in at any given time or any given location, any given language? Then we can staff properly. We can plan our shifts accordingly. In-day shift management. So you're the shift manager now. You want to know if you're going to let people take a 2-hour lunch break or not. Maybe it's fine. Maybe you're expecting a peak because something is going to happen. Again, improved SLA, reduced operational costs, all of these things can come into play. Which products or content, think about media companies, each user is likely to buy or consume and when. We can recommend the right thing at the right time to the right person and increase cross-sale and reduce churn. Which campaigns, think about before you run a campaign, you could maybe model and see which campaigns are likely to be adopted or responded to by each which user. Then you can send the right message at the right time, and higher click-through rate, CTR, or reduced spam fines can be some of your KPIs for this. Now, you're here, so you're biased towards machine learning, right? You're curious about machine learning. You want to do, even if you answered later, which means that you kind of just dreaming about it, you're still not concretely thinking about this, but you're still biased towards machine learning. So I don't want you to think that, hey, every use case that can fit in this process, let's do machine learning, because there are many things that you can just say, you know what, it's not really what we need to do here. So be your own police and ask yourself, to ML or not to ML. If you can write 10 lines of if-then to replace the machine, don't machine learning it. Just write those 10 lines and just heuristically code this. If the data scales gradually, predictably, you don't need to machine learning it. You can, again, pre-think about all the turns and twists that the user will take. If the value resides in the segments or the cohorts, if you're an insurance company and you're saying all young drivers are risk A, that's what my actuary says. No need to machine learn, just ask the age. But if you're saying, you know what, actually, if I'm an insurance company for driving, and there's some young drivers who drive really safely and some that drive recklessly. So it's not, yeah, there is some correlation to age, but if we can actually be more granular and identify the value or the patterns, the behavior on a personal level, not on a segment level, then this is now becoming machine learning worthy. Is your need, your use case, confidence tolerant? Do you require 100% accuracy? What are you going to do with false positives and false negatives? Do you have a means to mitigate those risks or to communicate that to your users? People used to say that machine learning is not good for healthcare. Actually, about 2 years ago, the FDA in the US approved a retinal scan, the back of the eye scanner that is done by a bot, the machine, without a doctor in the picture, to screen for diabetes, which is something you can see in the fundus in the back of your eye. And why did the FDA approve it? Because they ran statistical research and saw that even doctors have false positives and false negatives, right? Cases that they referred someone saying, hey, you have diabetes, and they got him into treatment, which they didn't have to, and cases that they thought they didn't have and they missed. So the minute they saw that a machine can outperform the human in those false positives, false negatives, they call it confusion matrix results, then it's starting to be in the space of machine learning worthy. Black box tolerant. I'll mention a little bit about the explainable AI. Today we can open the black box a little bit. We can do like reverse engineering on the black box. So again, if we are a bank or a credit company, and we need to explain to the regulator, how does our model work? We can't just say it's a black box sort of thing that decided whether this person gets a loan and that person does not. The regulator actually requires, what data did you use? Did you use gender, yes or no? Did you use age? Because you're not allowed to use, or because you're only allowed to use in conjunction with other data elements, so it's not only biased towards that. So you need to show that. There are ways to look, called CHAP models. We look at what features resulted in or helped the result of the machine to reach the result. And then we can explain the model. We can explain just one prediction, or we can explain the entire model, but there are ways around it. And of course, if you don't have the data, don't even think about machine learning. Machine learning requires a lot of data. Typical use cases for machine learning, we roughly say there are three types of machine learning families: vision, language, and all the rest. And all the rest usually is data, right? Ranking, personalization, anomaly detection, clustering, grouping of different data types together, and so on. All right, so we have the use case. We have tested ourselves around our pre-bias towards machine learning. Now we need to design the POC. So I mentioned earlier, I love Marty Kagan. I love his approach for this. Let's de-risk at least one key assumption here. Will our customers want to use it, pay for it, and pay not just in money, maybe they pay in willing to give their personal information, and willing to be subscribers to a newsletter or something, right? But will our customers agree to do something in return for this value that we generate for them? Will they understand how to use it? Is it feasible to build it? This is where we work with the data scientists. Can we really predict this level of accuracy? Can we do a machine that imitates human in this case, in that case? And viable. Will our stakeholders agree to sponsor it? This is the question that, if you remember the internal FAQ questions that we had. So what is the value to our company? How do we make money of it? Maybe this is just customer satisfaction thing, and that's fine. But let's ask this question. Let's see if this is something that is the most critical piece in this project. But let's think about, how do we POC this value assumption? Maybe it's not even about building any model. And think about a Wizard of Oz POC, which is the example when coffee machines started coming out. People said, you know what, the biggest question is, will people really want coffee from a vending machine and not from a barista, not from a person? So instead of designing and developing all the mechanics of the machine, the joke, right, the legend is that they put a little person in that vending machine who poured the coffee and stuck it out for the person to pick it up. And this way, you, without going through the engineering headache of building the vending machine, you test the assumption that people will trust a vending machine for coffee, right? So this is one way of thinking about a POC. The idea is to time box this 4 to 6 weeks. You don't need to build a machine learning model from scratch. You don't need to retrain a machine and get the PhD people, hire them, and million images of cats and dogs. Many models pre-exist. So you can take off-the-shelf pre-trained models. AWS has plenty of them, we call them AI services that are available via API. Yes, they may cost a little more, and yes, they may be required to tweak to your own data, but you can basically get up and running within hours. And if it's a little more complicated, you need customized version for your own data within a few days. Once the POC is done and you're happy with the results, you can decide whether you want to stick to this, let's call it pre-built managed sort of service, or you want to take something a little more robust and build something that's more customized to your own need. But as product managers, we don't want to be held back because, hey, we don't have an army of PhD people to now build a model. No, there are many typical use cases that are pre-built. Again, if you have something that's really anomalous, then you may have to do a bigger model to begin with. But most typical use cases, language, taking voice to text, text to voice, reading OCR, images, video, tracking people, recommendation engine, fraud detection, forecasting, time series forecasting, all of those things have already been figured out. You can literally use out-of-the-box pre-built models to do, at least for the POC, if not beyond that. Now, a few of you asked about collaboration with the data science team. So let's talk a little bit about that. We as product managers usually follow this Venn diagram. We have some tech understanding. We're not engineers, but we have some tech understanding. Some of us came from UI and learned a little bit tech. Some came from engineering and learned a little bit UI. we have UX understanding, which is something very unique usually to product managers, and we have a business acumen. We understand our customers, we understand what moves them and how do they make decisions. Data scientists have slightly different but albeit similar Venn diagram. They have a hack capability. Again, they're not engineers, but in order to build models, they can write some code or they can configure stuff, so it's not completely foreign language to them. They have domain expertise. By the way, the hacking is similar to our tech, and the domain is similar to our business, though this is more around the data in that domain. How does the data, what data exists, what data available for fast starting of model development, what is the quality of this data? They have this understanding, and they have their statistical or mathematical unique capabilities, just like we have the UX, and that is kind of a completing element. We need to choose the hypothesis together, especially if we're thinking about a feasibility POC, right? Can we build the model that is accurate enough to generate the value that we need? Now, we own the voice of the customer. Data scientist owns the art of the possible. Machine learning has endless or really fast number of research papers published on arXiv. And every day you hear about something new that you didn't even think was possible yesterday. So you want your data scientist to be at the cutting edge of what's possible. You want to be at the cutting edge of what your customer really needs and why they need it. Right? Remember the paradigm shift. If you ask people back then, Ford, when he invented the first car, asked people, what do they want? They'd say faster horses, right? So you got to remember that you need to understand why the customers need faster horses. They want to get from A to B faster. So horse is just a solution. Let's understand the problem. But when you marry the two together, the really deep understanding of voice of the customer with the cutting edge art of the possible, this is where magic happens. So only when the two come together, PM and data scientists, to brainstorm around what can be done for this problem, can we really come up with the right, I don't know the right, but at least a place to start validating something. A lot of you asked about data, so let's talk about that. When we look at data, we ask these questions. Is the data available internally for us to use? Is it public? Do we have the permissions to use it from GDPR, privacy, HIPAA if you're in the healthcare space? Is it relevant for the use case? Freshness of the data is critical, especially if we're talking about time series. Think about COVID. If you're trying to model something that predicts behavior today, probably data from the peak of COVID is less relevant. So you want to take maybe older data, just a little bit of anomaly in the behavior. Usually saying that the most recent, freshest data is best, but you got to be relevant for the use case. You have to go deep into what use case and what data is available, but then what data of the data is available is really relevant to what we're trying to achieve here. Is the data representative? If you're in the space of fraud detection and cyber, by definition, those events are rare. Your anomaly detection, right? It's an anomaly. So it's very hard to identify or pre-find a lot of data from that rare subset, from the risk, from the fraud attacks, or the accidents in insurance and so on. These are rare. So there are ways to mitigate this risk. For example, you can double count those rare instances. You can overweight those classes that you don't have enough of them. But when you start playing and massaging the numbers, as often data scientists call it, you're entering a risky zone. Right? I'm not saying you shouldn't do it. It's just saying do it with your eyes open. And there are certain ways, certain mechanisms within data science that are built for that, such as holdout set. You only train on 80%, 70% of your data. And then you take, let's say, the first slice of 10% to test it. And then you kind of improve based on the 80%, and that 10% is testing, but you still have last 10% is completely clean just to validate just before you go live, right? So there are mechanisms, but the risk, the more massaging of the numbers you do, the riskier you are of overfitting. Overfitting is training your model to fit only the data that you gave it for this. It does not generalize well to the world that you are going to real world data. In which case, in addition to the holdout set, you may want to do very gradual deployment. Only divert 5% of the traffic to the model and see if it really behaves like you want it to behave in real world. Or even if you're over cautious about this, you may just run the model in silent mode. So you're still doing the business the way you've done it before, but under the hood, you run the model. Then retroactively, you say, what if we had it through the model? What would that behavior look like? Missing data is probably the biggest challenge. And within the missing data, probably the missing label. because remember, we talked about the label in supervised learning, where you want to train the model based on the real answers. But very often this requires manual work, risk analysts looking at fraud behavior data and saying, yeah, this is fraud. That is a long and tedious process. So there are ways to help manage this better, not do it for you, but help do it better. One of the tools we call SageMaker Ground Truth, which is a labeling workforce management tool. Maybe you can want to send the labels to 3 different people and then have a majority vote or consensus vote. There's active learning that after you start labeling manually, let's say you have 1,000 images or 1,000 data points, after 200, there's a model being built under the hood that's trying to then predict the remaining 800. And maybe out of that 805 are really easy based on the first 200. So the manual work only needs to do 200 and then 300 at the end. So there are ways to reduce that effort of manual labeling. You can get third-party with data. Some elements like Amazon Personalized, which is a recommendation engine, the pre-built, pre-trained model, you can actually start to make recommendation based on popularity. What was most purchased book in the store last year, last month, whatever. Whilst the data is being collected under the hood, and the minute there's enough data, critical mass, and in the case of Amazon Personalized, it's not a lot. It's I think last I heard it was 1,000 instances of purchasing. 25 unique users, each having at least 2, and overall 1,000 images. So it's not huge, not millions of images. And then think about it, the car is continuing to drive, but you're changing the engine under the hood, right? From popularity to machine learning based without any friction from the user standpoint. And there are more advanced or cutting edge technologies. You can use synthetic data, generate data artificially. You can use reinforcement learning, which is when the machine is asked to design a policy based on a reward system. So when you have repetitive games, repetitive chances to tell the machine wrong, right, and the machine can continue to try, like a recommendation engine is a good example. That can be reinforcement learning. The latest cutting edge on how fake people and fake news often is created is GANs, generative adversarial networks, is having 2 networks, 2 machines, one trying to randomly create images or behaviors, and the other is trying to detect whether that is fake or not. And once it tricks that other network, all of a sudden we have a fake person. So that's another way to get generate synthetically some new data sets. Let's go back to the use cases that I've mentioned earlier on. And let's see, what does the data considerations look like for them? So we talked about which customers are likely to churn. Let's look at historic billing data from our customer. If we're in a telco, maybe we can look at network, customer experience. Maybe there's content that we can use and maybe pull it across different customers if we are a telco provider and you have multiple customers. And the label will be historic churn. So all of those features about the users, and then whether historically somebody churned or not will be the answer to the test. If we talk about which agent supports to put in front of which ticket, so the training would be the historic routing, agent profiles, user contextual data, like there was a campaign running now, or this user is calling from this location, and that location we had a downtime. So this is contextual data on the user side. And then what would be our label? Let's think, what would be considering a good match between a rep and a call? Maybe it's the length of the call. Maybe it's a survey that we run. Maybe we have another model that just looks at the sentiment of the conversation. And if the sentiment is positive or ended positively, we consider that a good call. And then we're having a good positive label and so on. Or maybe we just look at the last 30 days, what happens after the call. How many calls are coming in? Again, historic data, context, events, promotions that we're running. And then usually in time series, we take the recent data, and COVID aside, because that kind of skewed a lot of things differently now. But usually we take the last time series to be kind of the label for that. Which product, the content the users are more likely to consume. Again, we can look at the product and user metadata. What do we know about our users? What did they purchase in the past? Anything we have in their profile. What do we know about the products, color, shape, weight, price, all of those elements. Historic interaction. This person bought that, but this person really similar to that person. So if he bought that, maybe he wants also to buy that. That's kind of how do we look at those interactions? And again, recent interactions can be the holdout set for training this. Which campaigns have best potential, similar to the one above? Campaign metadata, user metadata, and past interactions. So we have a model. We optimize it for the right metrics with the support of the product manager and the data scientist. How do we go from model to product? In the middle is user trust. One way to earn user trust is to add a human in the loop. We're saying if the model is not sure the confidence, remember the false positive, false negatives, the model might have more false positives than we want, then just divert this specific decision to a person. I'm an insurance company. I want to fast track certain claims. If the model is really sure that this claim can be automated, does not need to go through an adjuster, a manual person to look at the claim, fine. But if the model says, hey, you know what, I'm only 90% sure, send it to an adjuster. If not too many calls get to an adjuster, it still might have a good ROI. But you may also decide, you know what, I'm going to write a rule that overrides all this decision. I'm hiring data scientists, and I want to filter resumes automatically, which is great. But if the applicant has a PhD, I want the person to look at that, even if the model is 100% sure. This is like really something I want this on the desk of a human person. So that will be an example of a key value pair that you want to divert to a human in the loop. And if you still not enough trust in overall AI in the company, then you might want to do a random sampling, 10%, 20% first, and then reduce it to how many inferences, how many indications from the model go out to a human in the loop. There are other elements of earning trust. Human in the loop is the first bullet point here. Others are bias detection. We talked about imbalanced data across different classes. If you have an anomaly, a small risk group, and you want to double index on that, so being able to detect that bias that you're introducing or the bias that you already have in the data, because you're now looking at, talk about auto insurance, for example, motor insurance, and you're thinking that every 5 years is an age group, right? 20 to 25, 25 to 30, and so on and so forth. But from 20 to 25, your N is very small because your insurance book right now is of older people. You want to highlight that when you start to train. So you may play with the data and say, you know what, instead of looking at 20 to 25, I'm going to look at 20 to 30, 30 to 40, and so on and so forth. But being able to detect that can improve how your model works because it has less bias. Explainability, I talked about that earlier on. I'll just mention that in high level now. Global explainability is telling the regular, here's how my model operates as a whole. So it does not violate any rules of data that is influencing my decision. Local explainability is replacing that specific instance. So why did I not get a loan? Why was I denied? Maybe the fact that the model does not or does look at gender is important for the regulator, but in my case, it did not influence the reason they denied me. They denied me based on the location. So when I'm trying to do explainability for a model, it's important to understand why are we doing it. Is it to answer that specific person who was now affected by this prediction? And then maybe there is a simpler, shorter answer. In your case, this is the reason. Or do we need to explain something a little more complicated, which is how the whole model operates? And we'll talk about drift detection in the next slide as well. So this is a nice quote to get us into the last piece. And in about 3 or 4 minutes, we'll wrap up here and have some time for Q&A, as I promised the team here. It's not about who says that the product works or doesn't work, the model works or not. It's actually the feedback from the customer. This is why product managers are usually the masters of the analytics, who kind of have a way to tell people, you know, this is what the analytics show us, right? This is what data tells us about user behavior. In the world of machine learning, it all starts with the data, right? We asked ourselves, do we have the data and the labels needed for modeling? And who labels and how we label, we talked about that in earlier slides. And then we take this data and we build a model. And we ask ourselves, can we generate a meaningful prediction, right? Can we come up with a model that has an accurate enough with false positive, false negatives that makes sense? Can those predictions, as they are embedded in a product with the earned trust, human in the loop, or the way we do the microcopy to explain that this is a machine-generated prediction, so people do not think it's otherwise? And if we earn the trust, do our predictions, our insights, change the behavior of the user in the way we intended it to happen? And if they did change the behavior of the user, they clicked on this, they watched this video, they checked this anomaly, they blocked this user because they thought it was fraudulent, they did something that we intended, the action that we intended them to happen, it generated new data. Because almost by definition, we changed the world. And if we change the world and change the behavior, how do we detect that new data, that new change in the data? And what does that mean for the model? Can we still run the same model, or do we now need to cascade? If that behavior has changed, then this specific user needs to move now to a different model. Or maybe we need to retrain the model and be more granular and fine-tuned about which classes go into which model. And all of a sudden, one model fit for all start position might end up splitting into two models for different types of personas, or for different behaviors that have changed, and continue to be more and more granular. So this is the feedback loop. This is why the feedback and the way we are impacting the behavior, it's very different in machine learning than it is in other products. So it's not just a question of, can we change the size of this button or put it more on top or more on bottom to get higher conversion. It actually goes back to the science. Do we need to retrain the model? Do we need to change the model? Do we need to cascade the model to other models? And many different considerations that need to go into place. So this is it. I think I was on time. I made a promise to keep this until 15 minutes after, so we have a time for Q&A session. With me on the call, Larissa Becker, who's based in Germany as well. So you, like I think most of you in the call. So here's her email. Here's my email. You're welcome to copy them. And if you have any questions or want to have any follow-ups on this. And like I said, I'm very passionate about this topic, so I write about this. I also have a Medium blog, but I just put this here, and you can capture my LinkedIn profile and go from that, accepting almost all people who ask to connect. So you can follow and read some of my stuff and comment. And I'd love to hear what you think about this session and about this topic in general. So with that, I'll hand it back over to Stefan.
Thank you, Oren. You can unshare your screen and then I can share mine. And we are posting your addresses in the chat as well.
Cool.
So I have to agree. There's one of the comments that we got on one of our streaming services was, this is by far one of the best and most realistic talks about AI PM. Thanks. So I think it was really a very valuable session. Other comments also coming through, fantastic session and topic. So I think it was a mouthful, but it was really very interesting and insightful. So thank you so much for sharing that with us. And then everyone on the different streaming services and on Zoom. So we're going to go into a Q&A session now. So you can think of questions that you would like to ask Oren that he could answer for us. If you're on YouTube or LinkedIn or any of those, you can post your questions there. If you're on Zoom, you can also post your question, or you can raise your hand and unmute yourself, and then you can ask the question verbally. Just to give everyone some time to think of the questions that they would want to ask, just quickly going to talk a little bit about product people again, and then we'll go into the Q&A. So just some of the use cases, also known as when to engage with us, where product people could really add a lot of value, is as an interim product manager. So when you are trying to fill a permanent position as a product manager, and it often takes a little bit longer, we can help fill in that gap. When your product manager or you as a product manager is going on parental leave, and we need to cover there for 3 to 12 months. Product coach or consultant, so to coach your product management team or create and streamline processes. And then also product discovery lead, so discovering the next impactful initiative or product, and to run low or no code pilot and MVP. And here are some of the customers or clients that we've worked with that we're really proud to have as part of our network. And then just some of the positive feedbacks from our clients, so you can read through them. I'm not going to read all of them to you, don't worry, but you'll see that a lot of them are also just about adding value very fast and quickly understanding situations and making onboarding really easy and quick. And that's in the beginning what I said, what we're really passionate about and love to do for clients as well. And then this slide, I think most people are usually the most excited about sharing this screen. So this is our team at Product People. So you can see we're quite diverse. We're all over the world. Most of the people are in Europe. I'm in South Africa, but we're legally based in Berlin. And you can see there at the bottom right corner, there is a spot for you. If you feel like you want to be part of this team, you can apply by going to boards.eu.greenhouse.io, lots of dots, /product people. And we're hiring on all levels for product managers. So, and with that, I think I've seen a few questions coming through. So one question is from Pratik, and he's asking, as a PM, how can you leverage Amazon Web Services for learning machine learning models better? Any PM courses or tools that you can recommend?
Yes, of course. Of course, we have plenty of training tools, both directly on AWS free. We've externalized what we call ML Machine Learning University. And we used to be our internal training capabilities. And every year we open up more courses out to the audience. If you want to ping us later an email, we'll be happy to share some of those links on where you can train. There are also many courses and certifications you can do with our partners. I personally did the A Cloud Guru when I joined. I really loved that one, but many of our partners have different machine learning courses. Some of them can be on the science, some can be on our tools. And then one of the things that I strongly recommend, I mean, always start with kind of the theoretic learning and so on, is to actually do one together. So go through this process of thinking, what is the right use case? What is the right business outcome for your company? And then pull us in. We have a lot of resources, data scientists and different prototyping teams and solution lab that can work with your team, data scientists and product managers, to build the first one together. I found that this is a very useful tool, even if it takes a little longer, even if the first one is clunky and doesn't fly as well. We probably could have built it faster on our own if you just gave us the data, but we see a lot of value in the sense that after this, it could be 1 month, it could be 2 or 3 months, depends on the size of the project. But after this short period of building together, you can actually take it from there and run on your own, right? So we're not giving you just a fish, we're actually teaching you how to fish in a sense.
Awesome. Thank you, Oren. And then there's another question from Azar, who's asking, what would be the golden rule or advice for stakeholder management in AI product management?
Stakeholder management, it really depends who are the stakeholders. So I'll try and answer this as broad as possible. Product managers, our role is to evangelize the product within the organization. Right? And usually the stakeholders we're referring to our internal could be the head of R&D that needs to decide to invest in this product or feature versus other stuff. It could be the head of sales that needs to then decide to train their salespeople to explain this to our customers. It could be the call center that needs to explain to the people why we're getting these calls and not those calls. So it's really a question of mapping out who is impacted by the product or the ML embedded into the product. Loop them in from day one. They should be in the discovery process as the people, the business stakeholders, right? They own the KPI, they're affected by it. So they contribute to the thinking, to the discovery. And most importantly, keep them in the loop on how you progress. You do the POC, what did you learn? This works, but this does not work. This is not as accurate, it's not ready for you yet, but here's how we improve. If they are part of the process, you're more likely to get their adoption and support going forward. The trick or the challenge, because these are words that are easier said than done sometimes, is that if you move with everybody, it takes forever, because now you need to coordinate every phase with everyone and update everyone on everything all the time and listen and take into all the opinions and so on. You end up sometimes not forgetting kind of where you started from. So my advice is there are different levels of engaging stakeholders. There are stakeholders who are just being made aware of the progress. They're on the newsletter. Once a month, you call the shots. You decide when and where, and you update people and everything that's going on, just so they're being aware of, like, FYI, right? What's going on. And then there's a small subset of stakeholders, usually the people who are impacted by the KPI you're trying to improve. They are partners in the process. If they do not accept, because remember, at the end of the day, it's a product that changes behavior, and they own the behavior today. They have a certain workflow that's going on. It's working, right? We're not inventing something. We are if we're a startup and creating something new, but there is a workflow. If there's a stakeholder, there's something that is already being managed. So you have to think about how be a lot of empathy to their situation and how the gradual adoption of this, human in the loop, metrics on what's going on, what's working, what's not working, and adjusting it. So there's, like I said, to recap, 1 or 2 stakeholders who are the business owners of a KPI that you're impacting are your partners from ideation through every learning phase of the way, and try and create a broader audience of people that are being updated unilateral, like you're sending them updates on what's going on. They can always voice their opinion, but it's more about just broadcasting your learnings out to the rest of the organization.
Thanks, Oren. And then we have another question from you who's asking, what could be the most common difficult challenges in a machine learning PM role?
There are typical answers, and then it really depends on the company. Typical answers are data. Not having the right data or enough data to start is the cause of most frustration. We really want to do it. We have data science a lot, but we don't have enough data to really get started. So for this, it's important to run those ideation sessions, identify what use case, is it actionable, is it viable for us, what data do we need, what labels do we need. Very often when we run these discovery workshops with customers, we end up identifying 5 or 6 use cases. Most of them are not ready for starting now, but, and that's critical, you now understand what data you need to capture going forward. So in 3 or 6 months from now, you're in a different position because you now start to capture this data. You're asking customers for permission, or you're starting to log new events in your analytics, or whatever it is needed to capture the correct data. So it is important to start now. Don't be frustrated if the data is not there yet. Make sure you understand how to capture it going forward. The second challenge that I'm hearing and seeing from companies is collaborating with data science team. Different companies have different org structures. Some of them have the data science team centralized and product managers in the BUs. Sometimes it's the other way around. It's okay to start this way in the first use case, maybe the second one. But the faster you move into an empowered team means that you have a data scientist and a product manager as an empowered small squad. We call it 2-pizza team in Amazon, but it's like a small team. Maybe you have front-end engineer, back-end engineer, designer, 2-pizza team, right? 2 pizzas team can eat 2 pizzas, not entire restaurant, just small subset of team. In the business unit, understanding the domain, iterating really empowered, meaning that they can release stuff, not do 1 release, 2 or 1 a year, but do 2 or 3 releases a week. Test new features, test out new metrics, test out different stuff continuously. So for that to happen, it's not only the org change, but it's also the platform around it. You don't want them to deal with IT for every little launch. CI/CD, everything needs to be automated. There's an entire world called MLOps, the DevOps of machine learning today, that's being surrounding. So to empower those teams, to allow those teams to really be able to run and do what they want without having to call in on IT or DevOps for every little thing. If you look at my last Medium blog, I wrote about MLOps and when is the right time to ask your company to build an MLOps platform, right? Because the first use case, not yet. What is the indication, for example, when your DevOps team have a long queue of tickets from data science team? That's just an example, but there are like 5 or 6 different indicators that you can use for that. And last, the final challenge of product management machine learning is if you don't have senior leadership support. It impacts the entire or most of the organization. It's not just a question of R&D and product management. Like I said, this goes out to how do you train the product, the salespeople to explain the product to the customers. If the product has an ML feature in it, now all salespeople need to be able to explain what is explainable AI, because maybe that is part of your sales pitch. If the product now is being supported by your call center and support reps, they need to be trained on what is machine learning and what is false positives and false negatives in the context of your specific feature. In order for the entire organization to be, whoever is needed, right, the relevant people in the organization to be ready for the launch, you got to have senior leadership support. CEO, COO, someone up on top needs to identify this as a strategic move and support that. So if you're a product manager loving AI and ML, wanting to start that, get that sponsor before you start, because otherwise you might be building a great feature, great model with your data scientist, but without the surrounding support, may not follow through.
Awesome. Thank you for that answer, Oren. I think everyone can get a bunch of learning from that. I'm going to try and squeeze in one more. I know we have 1 minute, but Gwyneth has asked, what are some quick wins or how to gain the respect of the machine learning data engineers and data scientists fast as a new PM?
So quick wins usually is to build a model and show that it works. But then they can use the pre-trained, pre-built models. But that does not get the respect or earn the trust, as we call it in Amazon, with the data scientists and data engineers, because they usually look down at these pre-trained models. They are proud of their ability to build better models than anything that's pre-built. So it really depends whose trust you want to earn. I think earning the trust of the data engineers and data scientists is probably if you have smart advice on feature engineering. Remember the example I gave with taking longitude and latitude into stadium. This was a ball game during a stadium when it was hot for the soft drinks. If you're able to help them identify how to take the data, the raw data, into features, and are really skilled at finding data, because think about the example I gave, you need to find weather data, you need to find overlay of where stadiums exist, and an overlay of when games occur. Then if you're giving the data scientist and even the data engineer sometimes do this work, these data sources that you found online, it doesn't have to be a data engineer to find those data sources, right? If you find those data sources and you kind of write this narrative saying, hey, here's the feature I think it will impact because ABC, here's all the data that you need, you just made their lives a lot easier and relevant, because they focus on what they're good at, is building those ETLs, those transformations on the data that get to the result. So don't send them to search for the data, or don't challenge them with thinking about the use case, which is kind of what you own. Again, I'm simplifying this because you probably need to do together with them. But if you want to earn their trust, let them focus on what they really do best, which is the modeling piece itself.
Awesome. Thanks, Oren.
You bet.
I think maybe she also said super helpful. Thanks, Oren. Yeah, so I think most of the comments that I've been seeing are all just about how awesome this talk was. And thanks for answering all the questions in so much detail, Oren. I think it really helped all of the people that have asked the questions. And thank you for your time today. And thank you for everyone else for joining tonight. I think it was an awesome session. Thanks again, Oren.
Thank you. And feel free to drop me a note, an email, or on LinkedIn about the session and what can I do to improve it going forward. Thanks.
Thanks, everyone.